Hi, I'm Rebecca Short, Water Quantity Engineer with the Ontario Government. In this segment on monitoring soil moisture, I'll show you some soil moisture monitoring data and how to interpret it. Different soil textures, sand, sandy loam, and clay loam, will have different amounts of soil moisture. The pale gray area represents water that is in the soil but tightly bound to the soil particles and unavailable to the plant. The medium and dark gray areas represent water that is available for the plant to use. Water in excess of the gray shaded areas will drain out of the soil profile. The maximum water that the soil can hold is called the field capacity. OMAFRA experience suggests that overhead irrigation may be triggered before 50% of available soil water is depleted, and drip irrigation be triggered before 20% of available soil water is depleted. That is to say, at 80% available. Let's work through an example. The soil moisture instrument reads 19% water by volume in a sandy loam soil. From Figure 3, we see that 19% is close to the value of field capacity in the chart. Likely, there is no need for irrigation yet. Instruments that measure soil moisture in centibars can be interpreted using Figure 4. Here you can see the curves for the different soil textures. Let's try another example. The soil moisture instrument reads 20 centibars in a sandy loam soil. From Figure 4, we see that 70% available soil moisture remains. For a drip irrigation system, irrigation could begin. For sprinkler or gun irrigation, the plants can wait a few more days. An in-field calibration will improve your interpretation over simply using the chart values. After installing soil moisture instruments, soak the area around the soil moisture instrument and take a reading 24 hours later. For clay soils, allow a longer drainage time of 2 to 3 days. This reading is the field capacity or maximum water the soil can hold. Graphing the soil moisture data over time will help you to analyze the data for trends and confirm the field capacity and the permanent wilting point. An irrigation event or significant rainfall will cause the soil moisture to spike. Following this, the soil moisture can drop quickly, depending on the crop growth stage. As the soil dries out, the soil moisture will continue to drop, but more slowly. This is an indication that it is more difficult for the plant to take water out of the soil and the soil moisture is approaching the permanent wilting point. Instruments that provide continuous measurements, log data, or transmit to a computer are best suited to this analysis.